the two-port network. At first, we introduce the admittance matrix, admittance parameter, also called as a Y parameter. For this two-port network, we use the phase method. Add 2 voltage source to each port, then the port current can be treated as the sum of each voltage source works. This means for this network, we try to use the voltage U to express the current I. Use the voltage U to express current I, and we assume the outside is 2 voltage source, so the current I1, I2 will be the sum of each voltage source works. So we call this as Y parameter because this voltage, this current. So these two parameters, they must be the admittance. We use Y to express Y11 to Y22 in matrix form. We call this as a Y parameter matrix. Pay attention, the Y parameter is determined by the inner component and the connecting. It has no relation with outside the voltage source. The Y parameter physical meaning and calculation. We have four parameters. How to calculate these 4 parameters? At first, we can assume the U2 is 0. Assume the U2 is 0. That means the U2, the right side, short connected. So we short connect the right side, only add the U1, and then from the circuit, we calculate the I1, I2 divided by the U1. We can go to the Y11 and Y21. Y11 is I1 over the U1. We assume the U2 is 0, and then calculate the Y21 is I2 over the U1. Assume the U2 is 0. So the Y11 is the input admittance. Y21 is the transfer admittance. And then we assume the left side short connected. I equal to Y11, Y12, Y21, Y22, U1, U2. Assume U2 is 0 at first. Calculate these 2 elements. And then assume that U1 is 0. Then calculate these 2 elements. Y12 is assume the U1 is 0, U1 0, and then calculate the I1. I2. I1 over the U2 is Y12. I2 over the U2 is Y22. The Y12 is also transfer admittance. The Y22 is the output admittance. So the Y parameter, we also call it as a short circuit admittance parameter. Pay attention, the short circuit means one method to calculate the Y parameter. It not mean the outside must be short circuit. Not mean the outside must be short circuit. It just means one method to calculate the Y parameter. For example, find this circuit Y parameter. According to the definition, we can short connect the right side at first. Short connect, then add a voltage source at the right side, at the left side. Short connect, add U1, then the Y11, this short. That means this short, I1 this position. So the I1 will be this current plus this current. It will be the U1YA plus U1YB. This will be I1. And I2 will be this I2. This I2 will be the minus YB U1. So the Y21 will be minus YB. And then short connect the left side and white source the right side. In this circuit, the I2 is this current plus this current. So the Y22 is YB plus YC. And the I1 is minus YB U2. So Y12 is minus YB. So for this circuit, the Y parameter is YA plus YB, YB plus YC. This is minus YB. This is minus YB. Minus YB. So this is the Y parameter for this circuit. For this example, found the Y parameter. We can get the equation directly from the circuit. I1 is this position equal to this current added to this current. This current is U1 over R, this current. And U1 minus U2, this is U2, this is U1. U1 minus U2 over the J omega L is this current. This current. So this 2. This I1 use U1, U2 to express U1, U2 express I1. And we can also express I2. I2 is G1, this current plus this current. This current is U2 minus U1 over J omega L. So this is a total expression. Use U1 to express I2. So this is the Y parameter of this circuit. We can find in this circuit, they are not symmetry. If the G is 0, if G is 0, the Y12 equal to Y21 equal to minus 1 over J omega L is symmetry. So this Y parameter is not symmetry because the G, if G is 0, it will be symmetry. But for this circuit, we can find the Y parameter is symmetry. They're equal. For the reciprocal two-port network, Y12, Y21. When the U1 equal to U2, I1 equal to I2, we call this reciprocal. So for the reciprocal condition is the Y parameter is symmetry. Y12 equal to Y21. Y12 equal to Y21 equal to minus B. We call this reciprocal. In the reciprocal network, only 3 parameters is independent because these 2 are equal. For the symmetry network, in symmetry network, except for the Y12 equal to Y21, Y11 also equal to the Y22 also. So for the symmetry network, these 2 are equal, these 2 equal. This means symmetry. This means only reciprocal. This is reciprocal, this is symmetry. There are only 2 parameters is independent in the symmetry network. The symmetry means the electrical properties symmetry. Symmetry circuit construction will have symmetry electrical property. Some unsymmetry construction circuit also have symmetry electrical property. Is also symmetry two-port network. For example, for this circuit, If you have such a circuit, this 6, this 3, this 3. So this circuit, the circuit is symmetry. Symmetry circuit. That means they are equal from the left and the right. Left and right. But for this circuit is not a symmetry. It's not symmetry. This 6, this 3, 3, 15. But when we calculate the y parameter, calculate y11 and y21 at first. Should connect the right side. We can calculate the y11, y21 at first. When calculate the y11, should connect so 6 and 3 parallel and 0 with the 3. Then calculate the right side, should connect the left side, y22, y12. We can find y22 equal to the y11, y12 equal to the y21. So this y parameter are symmetry. This circuit also symmetry. So the circuit construction is not symmetry, but the property, electrical property is symmetry. So this circuit is reciprocal and symmetry. Parameter 2, impedance parameter. The Z parameter. We try to use the I1, I2 express the U1, U2. We can add the two independent current sources to each port. The port voltage can be expressed by each current source working alone. Use I1, I2 to express U1, U2. We call this Z parameter. We can get the Z parameter from Y parameter directly. From this function, get the Z. Z will be the inverse. Z will be the inverse. The inverse of the Y parameter. This is a matrix form. Use I1, I2 express U1, U2. The Z parameter will be the inverse of the Y parameter. The Z parameter calculation and meaning. When calculate the Z11 and Z21, we can assume the right side is open. Why we assume it's open? Because U1, U2 equal to Z11, Z12, Z21, Z22, I1, I2. We assume the I2 is 0 at first. This is 0. This is 0 means open. So U1 is Z11 multiplied I1. U2 is Z21 multiplied I1. So Z11, Z21. Calculate Z11, Z21. And then this input impedance, transfer impedance. And then calculate the Z12, Z22 is assume the left side open the left side. I1 is 0. So U1 is Z12, I2. This is 0, this is 0. U1 is Z12, I2. U2 is Z22, I2. This output impedance. This transfer impedance also. So we call the Z parameter as the open circuit parameter. The open circuit means one method to calculate the Z parameter. It not means the outside must be open. Pay attention. This open circuit only means the outside one method to calculate Z. So sometimes we use ZOC to express the Y parameter. Sometimes use YSC to parameter. Short circuit Z parameter, open circuit, short circuit Y parameter, open sect z parameter. The reciprocal and the symmetry for the reciprocal condition is z12 equal to z21. Reciprocal symmetry is z12, z21, and z11 equal to z22. This symmetry. For example, for this sect, found the z parameter. The method 1. Assume I2 is 0. This is open. Only this side are the current source. So the U1 is I1ZA plus IB. I1ZA plus I1ZB. So U1 over I1 is ZA plus ZB. U2 will be the ZB voltage. Z21 is the U2 over I1 is ZB. Then open the left side. Add current source left side. Z12, Z22. This is method 1. For the method 2, we can add the current source at the two sides at the same time. This is I1, this is I2. So this current will be I1 plus I2. Get the K-word function. U1 is this voltage plus this voltage. The U2 is ZC voltage, and this ZB voltage, So we can go to the U1, U2 from I1, I2 directly also. So from this sect we can calculate the Z parameter without the open sect method. So for this Z parameter we can find ZB Z12 equal to Z21. So this sect is reciprocal. If the ZA equal to ZC, this part will equal to this part, Z11, Z22. It will be a symmetry network. Find this sect Z parameter. Our function U1 is ZA voltage plus ZB voltage. U2 is ZC voltage plus ZB voltage plus this dependent source voltage. So this will be U2. Write in the matrix form G11, G12, G21, G22. This G12 not equal to the G21. They are not equal, so it's not reciprocal. Not reciprocal, because they're not equal. For this sect, find the ZY parameter. U1 is R1 plus J omega L1 I1 plus J omega M I2. U2 expression. So the Z parameter will be simple. But for the Y parameter, it will be difficult to calculate. We can get the Y parameter from the Z inverse. Y is Z inverse, so it's complicated. Pay attention, not all two-pole network have Z and Y parameter. For example, for this sect, I1 equal to minus I2, I2. The I1 will equal to U1 minus U2 over Z. U1 minus U2 over Z. The Y, this Y parameter. Use U1, U2 to express I. But we can find the Y inverse not exist. That means the Z parameter not exist. This means we can't use current to express current to express voltage. Why? Why? For example, for this circuit, we tell you this 10 ohm, this 1 ampere. So this will be minus 1 ampere. This U1, this U2. So can you find the U1 and U2 from this circuit, from this current? It's impossible. It's impossible. So tell you the current, you will not know the voltage. For this circuit, U1 equal to U2 equal to Z multiple I1 plus I2. This I1 plus I2. So the Z parameter is simple, but the Z inverse not exist. Not exist. This means we can't use the current. We can't use the voltage to express. For example, we tell you this 10 ohm and tell you this 10 watts, this 10. This side is also 10, So this current will be 1 ampere. But for the I1 and I2, we don't know. We don't know the I1 and I2. And for this circuit, U1 equal to NU2, I1 equal to minus I2 over N. The Z and Y are all not exist. They are all not exist. That means, give you the I1, I2, you can't calculate the U1, U2. Give you U1, U2, you can't calculate the I1, I2. So we need to introduce some other parameter to express the circuit. And first, the transmission parameter. We use T to express transmission parameter. We define U1, I1, use the output to express input. Pay attention, this has a negative. When we write in the match form, we have a minus in this position. Why we have a minus? Because the definition of the two-port network is the I2 flow into the network. But in the actual practice, we always assume this kind of flow in and this kind of flow out. I1, this I2 sharp. We always discuss I1 and I2 sharp relation. The I2 sharp is this I2 inverse. So we use inverse here. We use A, B, C, D to express the T parameter. Pay attention, we don't use T11, T12. We use A, B, C, D to express. And for this A, B, C, D, this position have a minus. This T transmission parameter represents the relation between input and output. T parameters meaning and calculation. When try to calculate A and C, we assume I is 0, I2 0. I2 0 means open, I2 0. Then calculate U1 means I2 is 0, so we should add U1 here. Or add I1 here. Calculate the U2, I1. So get the AC. And then assume the U2 is 0. This is 0, so it's short connect. B. Then we go to the B and the D parameter. The short circuit match to get the B and the D parameter. The A is transfer voltage ratio. The D is transfer current ratio. C is transfer admittance, transfer impedance. For the reciprocal and the symmetry, for the Y parameter, the reciprocal is Y12 equal to Y21. We can use the Y parameter to express the T parameter. So the A, B, C, D. Just use the Y parameter to express T parameter. From Y to get the T parameter. From Y to get the Z, it will be simple. It's Y inverse. For the reciprocal is Y12 equal to Y21. So we can get the reciprocal and the symmetry condition for the T parameter. This is for the T parameter. Find the T parameter of the transformer. U1 equal to N U2. I1 equal to minus I2 over N. So the T parameter is N001 over N. This is minus I2. So this is the T parameter of the transformer. It will be very simple. Very simple. This is the T parameter. For this circuit, find the T parameter. Calculate A and B. Calculate AC at first. Open the right side, add U1. Then calculate I1, U2. Get the A and C. And then short connect the right side, add U1. Cut the I1, I2. Get the B and D. The T parameter. Hybrid parameter. The O is used for the transistor circuit. For the hybrid parameter, use I1, U2 to express U1, I2. Is matched form U1, I2, I1, U2 to express U1, I2. For the calculation, assume U2 is 0 at first. Add I1, calculate U1, I2. And then assume I1 is 0. I1 0. Add U2, calculate U1, I2. Get the H12, H22, I1 0. For the reciprocal and the symmetry condition, this is reciprocal and symmetry condition for the H parameter, hybrid. For example, find out the hybrid parameter of this circuit. U1, I2, U1 equal to H11, I1 plus H12, U2. In this circuit, U1 is R1, I1. I2 is U2 over R2 plus this beta I1. So this H parameter, I1 is plus 0 multiple U2. This H parameter. Okay, we have introduced for the two-port network. At first, we have introduced a definition. We have defined the one-port network, two-port network, and the common four-terminal network, and the relation between the two-port and the four-terminal network. And then we introduce the parameter parameters of the two-port network. Two-port network. There are total 6 parameters. Use the U1, U2 to express the I1, I2. This will be the Y parameter. Use I1, I2 to express U1, U2, the Z parameter, Y and Z. And then we introduce U1, I1, U2 minus I2. This express is a T transmitter. And then U1, I2 and I1, U2. This express is the H parameter. So we have introduced 4 kinds of parameter. 4 kinds of parameter. There are total 6. We can also use U1, I1 to express the U2 minus I2. We call this T sharp. Or use U1, I2 to express the I1, U2. We call this H sharp. And the T sharp will be the T inverse. The H sharp will be the H inverse. This will be simple, so we don't introduce them. So for all of you, you should know how to calculate the two-port network YZHT parameter. So this 4 matrix, 4 parameter is the emphasis. Emphasis of this chapter. Okay, today's class is over. Do you have any question? If you have any question, you can ask here. As I have told you, this chapter, all of you should have learned this chapter in your undergraduate course. So I introduce this chapter very fast. If you can't understand well, please review your undergraduate course textbook. Okay, if no more questions, I will close the 10th meeting.